Last time we built self-attention from scratch, 3 vectors per token, query, key and value, and a softmax that let every word decide how much to listen to every other word. Powerful. But there's a catch hiding in that word, every. If our model is supposed to predict the next token, letting a word peek at the words that come after it is cheating. Today we fix that with one of the most elegant tricks in the whole transformer, the causal mask. Remember what self-attention gave us? Every token could see every other token in both directions. For understanding a finished sentence, that's exactly what you want. But we're not classifying finished sentences. We're training a model to guess what comes next. And if token 3 is allowed to look at token 4 while it's trying to predict token 4, that's not prediction. That's reading the answer off the back of the page. Let me make the leak concrete. Say the sentence is, the cat sat on. The model's job at position 3 is to predict the word at position 4. But raw self-attention lets position 3 attend to position 4 directly, so the prediction becomes trivial. The future already leaked backward into the present. The model learns nothing because nothing was ever hidden. We have to physically block that path. Here's the fix, and it's beautiful in how simple it is. Picture the attention grid. Rows are the token doing the looking, columns are the tokens being looked at. We only want each row to see itself and everything before it, the lower left triangle. So we build a mask shaped exactly like that, a lower triangular matrix. PyTorch hands it to you in one call, torch.trill. Think of it as a glass staircase. You can stand on your step and every step below, but the steps above you are walled off. Now how do we actually enforce the wall? We don't delete the scores in the upper triangle. We poison them. Before the softmax runs, we take every score above the diagonal and overwrite it with negative infinity. That's masked fill. And here's why negative infinity specifically. Softmax raises a to the power of each score. E to the minus infinity is exactly 0. So after softmax, every forbidden cell isn't almost 0. It's exactly 0. The future doesn't get a small vote. It gets no vote at all. So watch the before and after. Before the mask, a full 8x8 grid, every cell glowing, attention flowing in all directions. After, the entire upper triangle goes dark, pitch black exactly 0, and only the lower left half stays lit. Row 1 can see only itself, row 2 sees itself, and row 1. By the time you reach the bottom row, it can see the whole past, but never a single step ahead. And if you think about it, this matches exactly how text is actually written. Nobody writes a sentence by knowing the ending first and filling in backward. You write left to right, one token at a time, each word chosen from everything that came before it. The causal mask just teaches the model to read the way humans write, forward in order, blind to what hasn't happened yet. One subtle thing that's easy to miss: even after we blank out half the grid, every row still sums to exactly 1. Softmax renormalizes over whatever's left. Take row 2. It's only allowed to look at 2 cells itself and the one before it. In our run, those come out as roughly 0.36 and 0.64, and notice they add to exactly 1. It isn't attending less because the rest got zeroed. It spreads its full attention budget across the cells it's allowed to see. A spotlight with the same total brightness, just one that physically cannot swing forward. BZO overview. Okay, let's see the whole thing in code. It's one short file, causal rtn.py. We'll set up a tiny batch of attention scores, build the triangular mask, apply it with masked fill, run softmax and print the resulting weight matrix so you can see the zeros with your own eyes. Top to bottom, no magic. First, imports and the setup. We bring in torch and torch nn.Functional as f. That's where softmax lives. We fix the random seed so your numbers match mine exactly. Then we define the shape. A sequence of 8 tokens, each with a small head dimension. Tiny on purpose, small enough to print and actually read. Next, we fake some attention scores. In the real model, these come from query dotted with key, scaled by the square root of the head dimension. Exactly what we built last episode. Here we just generate a random 8x8 score matrix and scale it the same way, so the focus stays on the masking, not the plumbing. This is the raw unmasked attention. Every token can still see every token at this point. Here's the heart of it. Torch.drill of an all ones 8x8 matrix gives us the lower triangular mask, ones on and below the diagonal, zeros above. Then masked fill. Wherever the mask is 0, the upper triangle, we overwrite the score with negative infinity. We use float indiv. So softmax will crush those cells to exactly 0. One line builds the staircase, one line walls off the top. Then the payoff. We run softmax along the last dimension across each row, turning scores into a probability distribution. Because the upper triangle is negative infinity, those cells come out as a clean 0 and each row's remaining values renormalize to sum to 1. We print the matrix rounded to 2 decimals and we add a quick assertion that the upper triangle really is all zeros. Then print the no future leakage confirmation, so it's not just a vibe, it's verified.